Here's an update on my tyvok S1, which is a Kickstarter laser cutter. I've made some modifications to mine, some to try and get it to work better. I added these 1-inch aluminum bars because the top kind of sagged down and would bump into the head. I wanted it to vent out the other side, so I laser cut these vents, ran the vent out the other side. The fans weren't strong enough, so I bought an inline fan to vent with. Now it's going pretty good. So I've been trying different materials. 3mm was actually very easy. I've got a 80-watt CO2 laser, and it felt very similar to that one in terms of performance. This is a 60-watt diode laser. But my thing I really wanted to do is try and cut large sheets of plywood, and that's what I've been experimenting with. This is 12mm ply. It's got some charring on the sides, but it's not really that bad on the back. There's a little bit on this side. That's running at 250 millimeters a minute at 80% power. So I probably could punch through a little harder than that. I tried it running 300 millimeters per minute at 80% power, and that's a failed attempt there. But actually the charring was very clean, but it left a few little stragglers that weren't quite cut through that I had to poke out. They came out all right, but I mean, I don't like to have to tweak it if I can help it. The astonishing thing was I tried 18mm ply, and it looks charred, but it's not really coming off. Pretty darn good, and that's at 150 millimeters a minute, 100% power. To test how accurate the laser is, on the 18mm, I sent 58.89, so the widths on these was 58.89, and when I measured it, the top of the cut, like where the laser punched in, is at 58.13, and the bottom is at 58.24. So we lost about, I guess that's almost half a mil in the charring and the cut, but there's only about a 0.2 millimeter variance between the top and the bottom of the cut. It's obviously different on each side, which that's acceptable for a lot of the stuff I plan on using this for, was like cutting the insides of complicated, props and stuff. So as long as I can get it very close to the right size, and that looks pretty good. So to test how well it performed, I just made a little simple box and cut it out, and that's not glue, that's just kind of held in with a little bit of pressure. There is some gapping. I'd have to compensate a bit more. The material is 12.15 mils thick, and I just set it to 12, which usually tightens it up just a tiny bit. And it tightened it up enough, but it's not as precise as the CO2 laser. You can see there's a little bit of charring on the edges, but not enough to really not keep trying. I feel like I can dial down some of that charring and get the edges a little bit tighter. But I feel like I could glue that up, and that would be more precise than what I would cut by hand. I'm excited. It's been promising. The idea would be to be able to do long structural pieces, struts and stuff that are really complex, that could then interlock with other pieces. So kind of like large form versions of this as structured pieces, and use this basically as a CNC. And at the moment, this looks like it might happen. So that's where I'm at now.